Hi and welcome. In this video, we are going to see the problem understanding part of this particular problem, combination of numbers, from the recursion section. Okay, let's read the problem understanding in this video. Fine. So, you are given an array of integers of length n and an integer k. Okay, so we have a length n array of integer and an integer k. You have to use your loop plus recursion skills to solve this problem. Fine. The task is to print all the subsequences of length k from the given array. All the subsequences of length k. Okay, subsequences, not subarrays. See sample test case for better understanding. Fine. In a subsequence, order of elements remain same. Okay. The input contains of 3 lines. The first is n, second is n space separated integers, and the third line is integer k. Let's see the input. So if we have 3, 1, 2, 3 and 2, so this is n, this is n space separated inputs, and this value is k. We need to print the subsequences of length 2, subsequences of length 2, okay, from this particular given array. So what are the subsequences of length 2? We have 1, 2, 1, 3, 2, 3, okay. So 1, 2, then 1, 3, then 2, 3. These are the possible subsequences. We cannot write 3, 2, 3, 1 or 2, 1. The reason being, it is written that subsequences order of elements remain same. Here the order of elements is reversed, so it should remain same. So therefore only this is the possibility. For example, if we have 6, 4, 5, 10, 11 and k value is 3. So what are the possible subsequences here? It is 6, 4, 5, 6, 4, 10, 6, 4, 11, correct? 6, 5, 10, 6, 5, 11, okay? 6, 10, 11, okay? Any more? Yes, definitely. 4, 5, 10, 4, 5, 11 and so on and so on, okay? 4, 10, 11 also, 5, 10, 11. So possible subsequences, we have to print all the possible subsequences of length 3, okay? So now this was the problem, this was the question, this was the problem. Here are the constraints, okay? Now let's see how do we approach this particular problem statement, okay? In the next video we are going to see about the logic building part of this particular problem. I hope you have understood the problem, and first you will try out this question, particularly this question, by your own, okay? So let's see how can we approach such questions of combination of numbers. So how can we do that? So we know that if k value here is 3, if k value here is 3, so we know by writing on paper or just by writing here what will be the answers. It will be 6, 4, 5, okay, 6, 4 and 5. Then instead of 5 it will be 6, 4 and 7, correct? Now 6, 4, 5 is done, 6, 4, 7 is done. Anything else possible? After 6 we can go for 6, 5 and 7 also. After 6 we can go for 6, 5 and 7 also, correct? Now, and can we go till 6 and 7? No, because there is no third element. So move, we can go to 4, 5 and 7 is also one of the possibilities, correct? So these are all the possibilities that we have for this particular question, where n value is 4, these are the elements, and k value is 3. Now if we have 6, 4, 5, 7 and 2 and k value is 3, now the possibilities increases. Why? Because we do have 6, 4, 5, then 6, 4, 7. Now also we have 6, 4, 2, okay? Then we have 6, 5, 7, 6, 5, 2, correct? Then we have 6, 7, 2 as well. Then we move to 4 combinations, okay, that are starting with 4. So there are combinations that are starting with 6, there are combinations that are starting with 4, there are combinations that are starting with 5, because k value is just 3, sorry, not 2, 3, okay? We cannot have a combination starting with 7 because we do not have 3 more elements after it, okay, nor with 2. So we can have combinations starting with 6, 4 and 5, correct? So now we know that a combination will start with 6, then we have to add 4 into it, then we have to add 4 into it, so it will become 6 and 4, okay? Then we have to add 5 into it, so it will become 6, 4 and 5. Then we need to remove 5 and add 7, then we need to remove 7 and add 2 to get 2 more combinations, correct? After all these possibilities are done, we need to remove 4 and increment to 5 for other possibilities. So how do we approach this? How do we approach this? Okay, if you guys can think that yes, if this is an index, let me point it out with something. So I is pointing to 6. Okay, I is pointing to 6 in 6 4 5 7. Let's say 6 4 5 7, and I is pointing to 6. So now here in the remaining one by one, I have to add it into this. Now for this you can use string as well as array. Okay, anything you like. So we can have 6 and 4. Fine. Now we have 6 and 4. So from remaining 5 and 7, we have to add 5. So it is 6 4 and 5, and 7 is still remaining. K value became 3. So stop and just print 6 4 and 5. Now we have to go back here. Okay, we have 6 4 only. Then after 6 4, we have to add the remaining element, that is 7. Now it will become 6 4 7. Okay, when will I increment? When will I increment to 4? I will increment to 4 when all the possibilities of 6 are over. Let's draw a recursion tree to generalize, to think, to visualize how it will happen. So it is 6 4 5 7. Okay, and we have here nothing but k equals to 3. Now here, let's suppose the first is 6 is added. Okay, I value is nothing but 0. 6 is added. Correct. Now we have the possibilities of adding 4 5 or 7. In here only we have the possibilities of adding after 6 4 5 and 7. We have 3 possibilities. We can add 6 4, we can have 6 5, or we can have 6 7. Correct. Now in the case of 6 4, we can add 6 4 5, 6 4 7. Correct. After 6 4, we have 5 and 7 possibilities. For 6 5, we just have one possibility of 6 5 7, and for 6 and 7, we do not have any other possibility. Fine. So for 6, we can print 6 4 5, we can print 6 4 7, and we can print 6 5 7. All these three have a k length equals to 3. Then we can move to 4, that is I equal to 1. And for 4, what are the different possibilities? We have 4 5, we have 4 7. For 4 5, we can do 4 5 7, but here there is no other possibility. So 4 5 7 is one of the other members that will be printed because its length is also 3. So we can draw a recursion tree like that. We can also draw a recursion tree for a little bigger case. Correct. Now here the first one is 6. So 6 has a possibility of 6 4, 6 5, 6 7, and 6 1 as well. Correct. Now 6 4 has a possibility of 6 4 5, 6 4 7, 6 4 1, and now we will have different possibilities for other cases also. 6 5 7, 6 5 1. Okay, then it will be 6 7 1 if k value is 3. Now for all the values where 3 is there, the length is 3, we have to stop and print it out. Okay, so using this recursion tree, can something happen? Using this recursion tree, can we think of something, of how to approach this problem statement? Yes, we can. So how do we do that? Let's see. Let's see with a smaller example of 6 4 5 and 7, and k value is 3. Okay, this one is a smaller example. So 6, I value is 0. Correct. Now we have a possibility of adding 4 5 and 7. Let's say we have one more pointer of j that is pointing to those possibilities, so we added 6 4. J value incremented to 5. We added 6 4 and 5. Correct. Now j is here, j is incrementing to 5. We are adding 6 4 and 5. Now as soon as k value becomes 3, that means the length of this array or the string, whatever we are using, becomes 3. We need to print it, and we can go back to this particular stack containing 6 and 4. Okay, we will say that increment j value. Now j value will move to 7. Okay, so add it, 6 4 and 7. K value became 3, so print it and go back. Increment j, there is nothing to increment, so go back. There is nothing to increment and go back. Okay, now see how it is actually happening. See, just this is really important to visualize. Once we go back, okay, do we need another pointer? Because j is now at 7, j is now across 7, so do we need another pointer to point to 5? How will we know that? Have you guys understanding? If we have a j pointer that is pointing to this one, the first array. Okay, so after 6, 4 and 7, here j has been gone outside the loop. Now when we go back, we need 6 and 5. So there should be a pointer that moves from 4 to 5. There should be a pointer that moves from 4 to 5, so that we can add 5. Now we have not used that pointer till now. We have not used that pointer till now. So for each and every call, do we need such pointers for each and every call, or how we are going to actually do it? Just think about this point now, because if you are using a j pointer that is common for all these, that is common for each and every recursion call, okay, will that work? Or do we need such pointers for each and every recursion call? For each and every recursion call, do we need such pointers? Okay, now we will think on this point, because till now we have understood that we need pointers, that two pointers are working, I and j. Okay, but is it working if the j value is global, let's say, or we need these loops in each and every recursion call? Do we need this loop in each and every recursion call, in each and every recursion stack? This is each and every recursion call. Okay, this is one call, then this is second call, this is third call, this is fourth call. Okay, this will be fifth call. So in each and every recursion call, do we need a full loop or not? Okay, so now we have to visualize that part. Fine, so let's see that how we will do that. So let's see this tree now. Okay, so see, I equals to 0, so 6 is added. Now we have 6, 4, 5, 7 as our original array. So in that, start with I plus 1, that is j. Okay, let's denote it by j, that is I plus 1. Okay, mark it. For this recursion stack, 6 is in the array or the string that we are using to store the result, and in 6, 4, 5, 7 we are marking at the next position of 6, that is j. Okay, now 6 and 4 are added, 4 is added, correct? Now here this is another recursion stack, correct? Now here the array or string that whatever we are using is 6, 4, and increment the value by 1. See here, I was 0, increment the value by 1. J was 4, now increment the value by 1. Okay, now we have 6, 4, 5. Now when this is printed and we come back, loop will increment j by 1, so this will now print to 7. Now at 6, 4 is already added, j is pointing to 7, so 6, 4 and 7. Okay, now when we go back again, now here there is nothing to be printed back, so we go back to 6. Okay, now here at 6 it will say now increment your value, so it can be incremented, so it will be 6, 5. Okay, now in 6, 5 also here it will be 6, 4, 5, 7. Okay, j value was incremented to 5, therefore 5 is added, so it will begin with j plus 1, whatever the value is. Okay, now here it is simple, 6, 5 and 7. Now it will go back. If j can be incremented, no, so it will go back. Now j can be incremented, yes, so we will have 6 and 7. Is it k equals to 2? No, it will say incremented, no other way to increment, so it will go back here. Now we will increment this loop I to 4. Okay, and for 6, 4, 5, 7, I plus 1, I is 1 now, I plus 1 is 2, so j will begin with this position. Now again the same thing, 6, 4 and 5. Okay, print, k value is 3, print, j value will be incremented, so it will become now, sorry, not 6, 4, 5, it will be 4 and 5. Okay, now 6, 4, 5, 7, j value will be this, so it will be 4, 5 and 7 to be printed out. Okay, so this is how the whole loop will work. So that means a loop will be there that will be pointing to the elements, and a recursion call inside that loop a recursion call. Okay, now that recursion call will take care of incremented for j plus 1 each and every time. So a loop plus a recursion call inside of it. Okay, because for each and every stack we need a for loop, for each and every stack we need a loop that will increment one by one. Okay, and we need a recursion stack that will call the functions again and again by adding the result. So 6, 6, 4 is added, so call the function again, so this array will be passed, and increment the j value from the previous stack. Okay, for loop will help in incrementing the j value from 4 to 5 to 5 to 7, and recursion will help from incrementing this value, that is from I equals to 0 to this. Okay, when we go to the next stack, we increment the value from here to here. When we go to the next stack, we increment the value from here to the 5. Correct. Now for loop is for incrementing the value from in that particular stack, that is from 6 to 4 to 5 to 7, from 6 to 4 to 5 to 7. Okay, from 5 to 7. But recursion is for incrementing the pointer in recursion stacks. Okay, in different recursion stacks. So therefore it is for loop, inside of it there is a recursion. Fine. So we'll try to implement it now, and then I will show you the exact dry run of this code using the stacks. Now I am just saying that this is a stack. Okay, in that I will show you step by step how recursion plus for loop will work inside the stacks. Fine. First, let's see the implementation part for this particular question. Okay, after that we will just use that implementation to dry run the code. I hope you understood why for loop and recursion will be used in this particular problem and how recursion tree was helpful in finding this particular approach. Okay, so let's see the implementation part now. So let's see the implementation. After implementation we will see its dry run, and that is a really important part, guys. Okay, so we are taking an input n, then an array, creating an array, taking all the array inputs and taking the k as the input, that is the length. So we are passing in our recursion function array, okay, an output string that will be nothing but our result. Okay, I value in starting it will be 0, pointing to the first element, array.length, and the k, that is the length of the result string that we want. I'm showing you the string representation and string method. You can do this similarly using an array also. Okay, store the result inside an array. Fine. Now what we are going to do is that whenever an element is added into the string, okay, we will decrement the k by 1. Whenever an element is added into the string, we will decrement the k by 1. Okay, now first element is added, k value was 3, so k will become 2. Then second element was added, say k will become 1. The third element was added, k will become 0. That means there is no need to add any more element. So the base condition becomes if k equal to 0, okay, simply print the result. Simply print the result. Okay, that is the output string. Fine. If k is not equal to 0, then what we need to do? Now that means we have to do the recursion part now. Okay, so in that for loop int j equals to I, j less than n, j plus plus. Correct? In this, call the recursion function, and in that function pass the array. Okay, in out add what you add, arr of, that is array of j. Fine. And increment the value of I to j plus 1. Also after it n is same and k minus 1 is passed. Fine. So this output will contain all the answers. That is, whatever the j is pointing to, it will add into the output string. We will exactly see this, what it is happening while doing the dry run part. Okay, I have shown you exactly this using a recursion tree, but if you have any doubt and if you want to just clarify how the recursion works inside a stack, please see that part. Okay, so now here when we run it to test it out, let's see whether we have done it correctly or not. Okay, so let's take 4, 6, 5, 4, 6, 7 and k value as 3. So we get 5, 4, 6, 5, 4, 7 and 5, 6, 7 and 4, 6, 7. So it is correct, but we needed a space, 5 space 4 space 6 in the output format. So therefore what we are going to do is I am going to add a space also after each integer. Okay, adding a space after each integer if you're using a string. Now if you're using an array, just input all the elements inside the array. While printing, you have to use a for loop for printing. Okay, and in that you can just implement the space method. Okay, so after printing, just give a simple space. So that is another method to solve this particular problem, to implement this problem. Okay, now if you have 4, it is nothing but 5, 3, 2, any example 3. So now we have a space 5, 2, 1, 5, 2, 3, 5, 1, 3, 2, 1, 3. So it is working just fine. Okay, so this was the implementation. Now we are going to see the dry run of this implementation, and that part is really important. Okay, let's see the dry run part. So let's begin with the dry run process. Okay, these are the stacks. These are all the values that we need to keep track of, and these values will be common. They are not global. They will be passed in each and every function, but these are common. So I have wrote them above. Correct. So now let's see each and every time all the steps and all the values. So in the beginning, k value will be 3. Okay, result will be empty, I is passed as 0, and j we will know. So let's see the first statement, if k equal to 0. Now k is not equal to 0, so first will not run. Second statement, j value will become I, so j value will take the value of I, it will become 0. Okay, update the result, so result will be added with 6. Then call the recursion function. So third step is over, and now call the recursion function, that is the fourth step. Okay, so once we call the recursion function, so k value will be k minus 1, so 3 minus 1 will become 2. Result will be passed with 6, correct. I value will be j plus 1, not minus 1, j plus 1. So I value will become 1, j we will know. Is the first step executed? No. Is the second step? Yes. For j equals to I, so j value will become 1. So j is now pointing to 4. We have 6, 4, 5, 1. J is here in this particular stack, correct. Now third step, update the result. So result is updated, so 4 is added, correct. Now call the recursion function in the fourth step. In the fourth step, call the recursion function. So k will become k minus 1, that is nothing but 1 itself. Now j will become, result is nothing but 6 and 4, that is passed. I value is j plus 1, so it was 1, so it will become 2. So in this particular stack, j is now here, correct. I is pointing to 2, I is pointing to 2, that will become the value of j eventually. So I is here, so 1 is not going to run. 2, j will become equal to I, j equal to I, so j value will become 2, correct. So j is becoming 2 now, fine. Now third step is update result, so j value is added, so it is nothing but 5, correct. And the fourth step is calling the recursion function again. Now when we call the recursion function again, k value was 1, k will become 0, result is nothing but 6, 4 and 5. I is nothing but j plus 1, that is nothing but 3. So the first statement will run. Yes, the first will run because now k is equal to 0. So print the result whatever we have. So result is nothing but 645. So 645 is finally printed. Okay, and simply return after this. So return after this. Okay, once we return, we always return to the point where the function was called. So this stack will become empty and we will return back to 4. We will return back to 4. Okay, now once we return back to 4, the loop will again run. So we will go to 2. J value will be incremented to 3. J value will be incremented to 3. So we will have this as the j value, correct. When we return back, so the value that was passed into the result was nothing but 6 and 4 from this. Okay, so we will have this value inside the result, fine. Now after this, what we will do? 6, 4 and 5, correct. So now j value is 1, so now second step is executed, j value is incremented, third step will be executed, we will update the result, so it will become 6, 4 and 1, 6, 4 and 1, correct. Now it is passed on. Now it is passed on in the fourth statement again. K value will become 0, result will be 6, 4 and 1. In this one result will be 6, 4 and 1. Remember, we are updating the result, so it will be 6, 4 and 1. So I value will become now 4 and j value will not be there anything because first statement will be executed and 6, 4 and 1 will be printed and we will return back. So this will become empty again. This will become empty again, correct. So we'll return back to 4. Again j value will be incremented to 4, but now 4 is less than n becomes condition false. So this for loop is over. We will exit the for loop. Program is over. We will return back. Okay. So now 641 is printed. So once we return back, this stack will become empty. This stack will become empty. Okay. The result value that was passed from here was 4. So 6, only 6. So here it is. Fine. So now j value will be incremented. Fourth step is over for this particular stack, correct. So we will loop back to second step. Now second step says increment the value of j, so it will be incremented to 2. Okay, result will be updated and it will be shared in the next stack. Fourth will call again, so k value will become 1, result will be 6 and 2. 2 is nothing but 5, so 6 and 5. Okay, I value will be 2 plus 1, 3. Fine. So first step no, second step yes, j value will become 3. Okay, third step update the result, and fourth call the recursion function. So when k value will become now 0, result will be update the result. So 6, 5. In the third step we updated the result 6, 5 and 1. Fine. I value will become 4. J plus 1 is 4. Okay, first step will be executed. 651 will be printed. 651 will be printed. Okay, return is called after print, so we will return back. Now 4, we are at 4. It increments. Go to the second step. J plus plus, j will become 4. 4 is less than 4, no, so we will not enter the for loop. We will exit the for loop and return back to the calling function. So we will return back to the calling function. Okay, once we return back to the calling function, now here again loop will increment, so j value will become now 3. Once j value become 3, update the result and call the calling function. So it will be nothing but k value as 1, result as 6 and 1, I value as 3 plus 1, 4, and j value as nothing. So first it will be incremented, no, k value equal to 0, so it will not be running. Second, j value will become 4. Now when j value becomes 4, 4 less than 4 condition is not true, so we will not move inside, for loop will exit and we will return back. So we will not print anything for 6.1 because there is nothing to print. Okay, so we will return back to 4 here again. Now again loop will be incremented, j value will become 4. Now 4 less than 4 condition becomes false, so this stack is also over. This particular recursion call is also over. So for 6 we have done everything we can. Okay, now we will go back to this particular stack. Here the result was empty in the beginning before updation. Now j equal to 0, so 4, again the loop will run, j value will become 1 now. Okay, result will be updated and the second call will be again made. So k value will become 2, result will become 4 because j value is 1, at 1 we have 4. Okay, so result will become 4, I will become 2. Is the first executed? No. Is the second executed? Yes. J will become 2. Is the third executed? Yes. Is the fourth executed? Yes. And it will be called to 1. Result will be 4 and j value was 2. So 2 is nothing but 5. 4 and 5. I value will simply become 2 plus 1. J plus 1 is nothing but 3. Is first executed? Yes. No, sorry. First is not executed. Second executed? Yes. J value will become 3. Third and fourth are executed and the call is made. So k value will come 0. It will become 4, 5. J value was 3, updation means 4, 5 and 1. I value will become 4, j value will not work because k equal to 0, 4, 5, 1 will be printed. So this is how the recursion will going to work. Okay, and it will be called back to 4 and the loop will again run. Okay, and this is how all the stacks will be completed step by step and the values will be printed step by step. Okay, so this was how this whole process is running. Okay, this is the recursion stack method to trace your code and each and every variable, what is the value of that variable in that particular stack. Okay, this helps you know that what you have to do and what is actually going wrong in that particular problem if it is not printing as per your thinking or logic. Fine, so this was the dry run process for this particular problem. Thank you.